I remember one of your lecture about the information paradox, we can burn the book and the atoms left, and then we can reconnect atoms to recreate the books.
As far as we understand the laws of nature, then in principle, you could set fire to a book and you could burn it. And if you could perfectly collect everything, the light and the heat and the atom, everything that comes off the book, all the photons, all the bits of smoke, the lot, right? And you could measure it all perfectly. And in principle, you could reconstruct the book. So obviously in practice, you can't, but in principle, you can. The wonderful argument triggered by Stephen Hawking's work initially in the 1970s about black holes is that true of a black hole? So if you throw the book into a black hole, then does the information somehow get stored? Does it ultimately get returned to the universe? Because black holes have a lifetime, we now know, so they ultimately evaporate away due to this process Stephen Hawking discovered called Hawking radiation. So ultimately the question is that information somehow imprinted in the Hawking radiation when the black hole's gone and all there is this radiation that's been emitted from it? And initially, the great paradox was that initially Stephen Hawking's calculation said, no, it isn't in the radiation. The information is featureless, informationless. It will not contain information. So it meant that whatever goes in essentially gets not only completely scrambled up, but erased. That was the calculation, right? So, Stephen Hawking. Hundreds, thousands of physicists have spent 50 years trying to understand what actually happens. And the current consensus now is that the information comes out again. So ultimately, in a very scrambled sense, it is imprinted in the radiation.